specific question tonight about the representation of triangular number. Let's just write. I'm going to write down an example. Let's see if I got this going on right here. Yeah. Okay. Yeah. This is a triangular. This is a triangle. The subject. It's a triangle of dots. But notice that all the dots sum up to 6. Okay, sum up to 6. So this is a triangular number, and you can, as long as you build something like this, the sum of the dots for a figure constructed like this is always going to be called a triangular number. And notice that this is the formula for it. Now notice that this would be equal to t sub 3, and this part that I'm looking at, this part here, this left-hand side here is this left-hand side equality is the definition of a triangular number. You can prove this pretty easily, that it's just the integer times its successor divided by 2. Now notice right here in this particular case, this would be equal to 3 times 4 over 2. And again, I want to emphasize that this is something that requires proof. This left-hand side is the definition of a triangular number in summation notation. And this, a little bit of work, it's not too hard to actually prove that this is the closed form answer for the number of dots in the triangle. Now, we want to know if the sum of 2 consecutive positive odd integers, each squared, can be a triangular number. Kind of an obscure sounding question, but if you want to directly translate it, this certainly is 2 consecutive odd numbers. 2n minus 1 and then 2n plus 1, and it says squared, each of them squared. Okay, so we have to look at this and see what pops out and just see if we can either say yay or nay to the question. Now, when you expand all this out, this is what happens. And notice that the 4n terms cancel. They're additive inverses of each other. So you'd end up with 8n squared plus 2 on the left-hand side. So if you multiply by 2, that would be 16 n squared plus 4 equals to the product k times k plus 1. Okay, now we can do a little bit more. And again, folks, just check me on the algebra. 4n squared plus 4n squared is 8n squared. 1 plus 1 is 2, but when you multiply by 2, you get this. And then you have something that's a little bit more manageable. Notice that we can take a 4 out. So you'd have 4 times 4n squared plus 1 equals to k times k plus 1. K times k plus 1. Now, what can we conclude from this? We know for a fact that if this is 4, and that would make k, that forces k to be 4. Okay, there's no other way. If we're looking for integer solutions to this, the only conclusion we can draw here is that k has to equal to 4. Right, and that would force that would force k plus 1 to be 5, and this would also force n equals 1. Okay, so this statement, there's an infinite number of real valued solutions, or perhaps complex solutions, to this equality, but these are the only positive integer solutions, namely n equals 1 and k equals 4. Notice that if k, the 4 and the 4 here by inspection, k is 4. And then, so if k is 4, that forces this part to be 5. But for the only way 4n squared plus 1 can be 5 is if n is equal to 1. And again, it would be plus or minus 1, but we're just looking for positive integer solutions. Okay, so the only triangular number, you see we got k equals 4 right here, so the only triangular number would be t sub 4 equals to 4 times 4 plus 1 over 2, which is 10. Okay, this is certainly equal, let me just write it on this side, equal to 10. Okay, so again, perhaps not a very interesting problem to a lot of you. Somebody just sat down and thought, well, the triangular numbers are pretty prevalent, and somebody wanted to know this for some reason. I'm not quite sure. There may be some geometric interpretation, but again, the only triangular number, the question was, can the sum of two consecutive positive odd integers, each squared, be a triangular number? And the answer is yes. And that triangular number is t sub 4. And you could figure out if n is 1, n is equal to 1 right here, what would that would give us 2 times 1. You could figure this part out too, where that's not necessary, but you could actually substitute 1 in here and get the two odd numbers. In this particular case, it would be what, 1 and 3, I guess. But anyway, that does it, folks. The answer is yes, and this is the only such triangular number that has that representation. Okay, thanks for viewing.